Welcome back to our channel, viewers. Now today let us deal with this radical geometry problem. So you've been given, in this case, you've been given ABCD is a square. So ABCD, you've been told is a square, and C is the center of the circle. So this point C, you've been told is the center of the circle. So how do we find the size of angle theta? So how do we find the size of this angle theta? Now this is very simple. First of all, let us drop the other diagonal of the square. So if you draw the other diagonal of the square from A to C, remember that the two diagonals meet at the center of the square. So you can let that center of the square to be center O. In that we don't have any dimension in this diagram, we are going to use ratios, because the point O is the center of the square, meaning from A to O is the same as from O to C. So when we say they are in the ratio 1 to 1 unit, then it means that any line from the center to the circumference of the circle is the radius. So it means from C to A is the radius, from C to P is the radius of the circle, from C to Q is the radius of the circle. Therefore, from C to A is 1 plus 1 is 2. So it means from C to P is also 2 units because it is the radius. Then from C to Q is also 2 units because it is the radius. Then when you apply the Thales theorem, you know that the diameter, you can see P to Q is the diameter because it is passing through the center of the circle. The diameter subtends an angle of 90 degrees at the circumference, meaning this angle at S is 90 degrees according to Thales theorem. So it means also again the two sides of a square meet at 90 degrees. So if you look at this diagram, triangle PCO is congruent to triangle PQS. So triangle PCO is congruent to triangle PQS. Triangle PQS. Now, we have the dimension P to C and C to O. So it means we can get the dimension S to Q using congruence. So you can see C to O, the length C to O will correspond to the length Q to S. Will correspond to the length Q to S over the length P to C. The length P to C will correspond to the length P to Q. So that one when you use congruence. So C to O we said to be 1 unit over P to C. From P to C is 2 units to be equals to Q to S. From Q to X is unknown. So Q to S we can let it to be X. So that is X over P to Q. So from P to Q is 2 plus 2, that is 4. So if you multiply both sides of the equation by 4, you will get X is equals to 2. So it means the length from S to Q is 2. Now from here you can see triangle PQS is a right angle triangle, and in this right angle triangle we know P to Q is the longest side, meaning the longest side is the hypotenuse, and S to Q is going to be adjacent when you are dealing with angle theta. So S to Q is the adjacent. So what does it mean here? We know the size of adjacent, which is 2, and we know the size of the hypotenuse, which is 2 plus 2. That is 4. So when we have adjacent and hypotenuse, what are we dealing with? We are dealing with the cosine ratio, because we know that cos theta is going to be adjacent over hypotenuse. And adjacent we found is S to Q, which is 2 units, over hypotenuse is P to Q, which is 2 plus 2, that is 4 units. So what do we end up with here? We end up with cos theta to be equals to 2 over 4 is a half. So what is theta? Theta is going to be the cos inverse over half, which is supposed to be 60 degrees. Thank you for watching, and see you again in our next presentation.